Hey, this is chapter 38. It's about competitive manufacturing, and we'll be discussing mostly competitive design, competitive manufacturing, and lastly, group technology. As you see, the seven subsection will not be covered, but the rest you will be responsible from the rest of these subsections. Let's start this topic. And with manufacturing, with design and manufacturing, we are trying to actually produce parts having high quality. So we need to find actually some proper ways to do it. In this chapter, we will be discussing competitive manufacturing. So in this one, in this approach, we are using various computer resources to do all design, engineering, manufacturing, process planning, and simulation processes so that they will be integrated together and the overall manufacturing and design process will be much better. If that's the case, then we will have high quality products with at less actually cost. So the quality is actually, with the help of this approach, built into the product. This is the main motto of this chapter. Actually, we'll be using computer in various design and manufacturing stages to increase the overall quality of the products. The first one is actually computer integrated manufacturing, and this is an kind of an approach, not a specific type of software. If you employ computer integrated manufacturing approach in your factory, then that means at every stage of your factory you are using computers. So we can say that it's the computerized integration of all aspects of design, planning, production, distribution, management, and other manufacturing organization. So we can say that it's a kind of a methodology, and we need to have obviously some proper communication systems between the software, computers, machines. So this network is highly important. And we need to have a proper database, otherwise you cannot control these equipment, software, store your previous designs, previous manufacturing data. So you need to have a proper extensive database. And you can easily apply this methodology for medium-sized companies and other large companies, but it's quite difficult to employ for small-sized companies. And if you have a proper strategic plan, then you can obviously benefit from the advantages of computer integrated manufacturing. Otherwise, you will be spending lots of money, but cannot take the advantages of computer integrated manufacturing. So what do we have in CIM? We need to have business planning and support. We need to have computer product design, manufacturing process planning, process automation and control, and lastly, production monitoring systems. These are all subparts of computer integrated manufacturing systems. For instance, if you do not monitor your resulting products, then you cannot say that this is a complete CIS system. The quality checks are highly important in this methodology. This is an example, for instance, CIM system, computer integrated manufacturing system. You see we have lots of computers for design, scheduling, planning, control, some other computers for the machine or the cell controls. We have automated guided vehicles around. They are carrying some parts from one station to the other. So all the layout is computerized, and we are trying to take the advantage of computer integrated manufacturing systems. This is a sub part of kind of an computer integrated manufacturing system. This is the first part, computer design and engineering. In this part, what we do, we make use of computer design tools, design software to design our parts to be produced. Obviously, we are using some computer graphics, interactive computer graphics, so that it will be easier for designers, engineers to come up with new designs. And further these days, we use computer engineering softwares. With help of them, we check whether the design part is capable of performing the assigned task. we do some analysis with finite elements. With once you design part, then you divide the part into some elements and then perform some analysis on these finite elements and check whether your part can carry the stresses on it, or check the thermal temperature distributions, do some simulations. They are all possible with computer engineering software. And for design, as you see, we have different types of designs. We may have 2D lateral model, 1.5D profile body. This is especially useful for rapid prototyping or 3D printing technologies. If it's a turning operation, you can design your part in 2.5D rotating body, or generally, if it's to be used on various machines, then it's better you have 3D surface models. And another thing in design is these days companies are usually working on similar products, and if they have a parametric design, then it's highly easier to switch, for instance, from the part A to part B. If you look at it, they are almost the same, just the dimensions are different. So if you have such a parametric design file, then it simply takes about 5 minutes to switch from part A to part B. In addition to design and engineering, we can further do some optimization. But obviously, in optimization, we can use the result of engineering software and then update our design. And this is sometimes called as, for instance, topology optimization. You have a specific part. You want to decrease the amount of material you are using on this part. How we can do that? You can perform some finite element analysis, check the stresses, and if you come up a conclusion that you have extra amount of material, then you can remove material from some part, and then do the analysis once again and check whether the weight and the stresses are fine for your application. And this is called as a kind of an optimization. And we also have some design review and evaluation kind of approaches. You may do some simulations, some extra analysis, and check whether your assembly is fine or not. These are all done again on the computer. And we said that for CIM systems, databases are highly important. You need to store all these CAD files, CAM files into such databases so that in your new production designs, in your new manufacturing applications, you can make use of this database. Now let me focus on computer-aided manufacturing. This is a subpart of computer-integrated manufacturing systems. As the name implies, we are making use of computers to make it easy for manufacturing operations. And the abbreviation is CAM. Sometimes we make use of CAD and CAM together. Since these two software are very related to each other, you need to provide CAD data to CAM software. And sometimes, according to the results in the CAM software, you need to give feedback to the CAD software and do some updates. And what do we have in CAD/CAM software or approach? We can easily program our numerical control systems, machines, CNC machines, and industrial robots. We can design some specific dies and molds for casting operation. And we can even design some specific tools for electro-discharge machining. So there are many things we can do with such CAD and CAM software. For instance, the Boeing 777 was actually designed and manufactured with CAD and CAM software. They didn't use any paper to design and prepare the manufacturing files. This airplane was designed and its CAM files were all generated on computer. So this is a nice example of computer manufacturing approach. And they were using CATIA software, But these days we have many other. You can use NX, SolidWorks, such kind of software to produce parts without using any papers. Then we have another part of this complete integrated manufacturing system approach. This is called complicated process planning. It's about actually selecting the manufacturing methods and selecting the right tools, fixtures, machineries of the manufacturing processes. Here's an routing sheet. You see there are 10 operations, and at the end of these operations, they will be producing, let's see, a kind of an, I think, yes, valve body. They start with some checking the forging process, do some rough machining, finish machining operations, some others boring, turning, drilling operations, grinding, and then later they do cleaning, and lastly, this is an inspection operation. The worker simply checks whether the part is fine or not with the help of some specific tools. So you can order these processes with the help of complete process planning approach. And we have some software, but this is mostly done with the help of engineers. But if you have some similar products, then things are much easier, since you can use the same order and then do little updates on the order and have the final route for the new product. This is the last part of this chapter. It's called as group technology. And in group technology, our aim is to decrease the design and engineering efforts. So what we do, we actually try to group the parts according to their design and processing similarities. So here you see we have two groups. In the first group A, they have geometric similarities. As you see, their geometric dimensions are the same, just their materials, the number of products are different, their surface roughness values are different. But if you look at the second set, they are geometrically different, but they have manufacturing similarities. What are they? For instance, they need to be machined on turning machine. They have some holes, so they need to be drilled. That's why we can easily group them together and machine them on the same machines. But the thing is that the tails might be different. We need to change the tool, for instance, from time to time, but at least they will follow the same route in the factory plant, in the plant. Let me talk about the layout, group technology layout, and the conventional layout. This is the conventional layout, or we can say that this is a functional layout. The lathe machines are grouped together, as you see here. I'm sorry. Yes, this one. The lathe machines are grouped together here. Milling machines, drilling machines, grinding machines, and assembly operations. But if you check all these arrows, we have some complexity. But if you look at this group technology layout, we have a neat layout. So again, we have some arrows. For instance, one part starts from lathe machine, and then after these operations, it can be shipped. Another group of parts can follow this path. I'm sorry, guys. Since we may follow this one. And then we may have another path here. So they are all possible in this group technology layout, and they are much simpler. But if you look at the other one, for instance, your part may go first lathe machine, then to drilling machine, then to milling machine, grinding machine, and then to the assembly. But it's much more complicated in the functional layout, but things are much easier in the group technology layout, especially if you have groups of products. This is the thing actually I mentioned. So what are the advantages of group technology? First of all, you have a standardization of design. So In the new designs, things will be much easier. You can easily develop new products from the previous designs. You don't need to spend much time, much effort on the new designs. The product designer can easily determine whether we have similar files in our database or not, since we have an extensive database for that. Another advantage is that new or less experienced engineers can easily benefit from the available knowledge and design new parts, new functional parts. Another thing, we can easily decrease the manufacturing costs with the help of this approach, since in a shorter time, we will be producing the same product. Another thing, we can standardize actually these process plans easily, and their efficiency will be much higher. We will be utilizing our machines in a much, again, efficient manner. There will be less lead time. The setup times will be decreased. We don't need to change the tools on the machine. So things will be much simpler, and the overall cost will be reduced. And we may use, obviously, similar tools for the members in the same group, similar machines, similar fixtures. So you don't need to spend some time to design new fixture, or you don't need to spend money to buy new machinery. Since they are in the same family, they can follow similar paths and they can be produced. Once you also includes CAD/CAM approaches and computer integrated manufacturing approach with group technology, then your overall productivity will be improved and the cost of your parts will be reduced. And this is the end of chapter 38. Thanks for watching.